Welcome to the Intelight tutorial on the MaxTime Logic Builder. This tutorial will cover just the very basics, getting started type operation. We'll go into more detail in more advanced tutorials, but let's have some we're going to jump right into MaxTime, and we're going to go to Controller, and we're going to scroll down, and we're going to go to User Program Configuration, and then we'll go to User Programs. We have 32 unique user programs that we can run on each controller, and we can name each of these. I'll put a name in here, an input to an output. So I'm going to tie an input when it's on, an output's going to come on. And I just hit apply. Now I go down to my user program definitions. And this is the screen that we're going to put our logic in. We can have up to 64 instructions per program. And we can drop it down and pick the different programs, 1 through 32, just like the last screen. But we're going to do program number 1. Try to keep it real simple. And the resulting is what's going to happen. So we'll drop it down and we'll pick a global variable. And we'll make a global variable 1. And we could have lots of instructions, but we're just going to make it equal to parameter A. And parameter A, we're going to slide down and we're going to look for a vehicle detector input, and we'll make it vehicle detector input 1. So what happens here when we hit apply, whenever vehicle detector channel 1 is true, global variable 1 will be also true. So we can turn an output on or off based off of that detector actuation. Just a simple example to get started. Well, this is a nice little program. We've got a global variable being on whenever vehicle detector 1 is on, but it's a lot more fun to have a little action in here. So we're going to go to cabinet. We're going to look at our I/O modules, and this happens to be a TS1 cabinet, and we go to our inputs, and vehicle detector channel 1 is input pin 1. So we will go and we'll go find an output. So we will just capture the very first output, and we'll change it from phase 1 red to global variable 1. So output pin 1 is our global variable, and input pin 1 is our vehicle detector 1. So now we will simply go up to our status screen, and we'll go to inputs and outputs. So this pin 1 here will come off and on when I check here. So I click it, hit apply, and there's my light on. I uncheck it, it goes off. Simple in and off. So we've written our very first program, tying an input to an output. Now we'll get into a little bit deeper. Let's look at the algebraic expression of the program we just wrote. The resultant equals an operator with 2 input parameters. In our case, we're only using the A input parameter, but we have up to 2. And sometimes it's expressed as R equals op A comma. Let's exchange the algebraic equation with the values we use. So our resultant was global variable 1. The operation is equal to, and parameter A was vehicle detector 1. If so, our equation is global variable 1 equals vehicle detector 1. Keeps it really straightforward when you break it down this way. Now we're going to change our expression to the reverse. Instead of being on, we're going to have it when it's off. So we're going to use the negative equation. So global variable 1, instead of equaling A, we can say the resultant is true when A is not on. So we can simply come down and hit apply, and this will give us the opposite effect. The reverse or opposite effect would be if we go down and go to our inputs and outputs, notice that global variable 1 is on, and we turn the vehicle detector 1 on, it goes off. So we turn it off, it comes on, we check it, the detector comes on, but the light goes off. So now we can do both direct, on or off. Now looking at our equation, global variable 1 is true when detector 1 is. Now let's take it to the next step and introduce the B parameter. So we're going to use A and B with the little relay logic, so ands, ors, and the first one we'll do will be the and statement. So we'll go back to our user program, and we'll go to our operator, and we'll drop it down and we'll pick the resultant equals A and B. So they both have to be on, and of course we have to have a B parameter to do the and we will slide down. We'll find our vehicle detector input, and we'll make it vehicle detector number 2. So for global variable 1 to be on, both vehicle detector 1 and 2 have to be on. When we hit the apply button, it does take a little bit of time to save this away because it's our biggest screen. So going back to our status screen, and we'll take a look at this. So now it's not on, even though detector 1 is on, but if I put 2, it comes on. If I remove either one of these, it goes off. So both detector 1 and 2 have to be on for global variable. The next one we'll do will be our OR statement. We will slide down, go to our user programs, and select resultant equals A or B. So now we're going to have a selection of OR and B, and we hit apply. Now that we've selected OR, we go back to our inputs and outputs, and we turn vehicle detector 1 on, and global variable 1 comes on. 2 by itself, global variable 1. We turn them both on, it's still on, so either one or both is an OR statement. So now we're going to go back and do our NOR statement. So instead of OR, it'll be a NOR. So resultant equals A NOR B. And we come down and hit apply. When we hit apply, it can take up to a minute to save away. It's our biggest save screen. So that's not. Now with our NOR statement, it means that they both have to be off for it to be true. So right now, global variable 1 is on. If I turn the first detector, it goes off. If I do the second detector it's off, or if both of them are on. So they both have to be off to make it true. It's an inverse relationship. MaxTime has additional relay operators, and they include the NAND gate, the XOR, and the XNOR. So we can pick a NAND. We can pick an XOR, so A XOR B, and a XNOR. So we can look up these parameters and look at the logic value of them. And of course, the NAND gate is a non-AND. It's a negative of an AND. The XOR is an exclusive OR, so one or the other, but not both. And the XNOR is either both on or both off. Let's look at these little tables, and the NAND gate shows that it's on in every condition except if they're both AND. So the reverse of an AND is both off, either one of them being on would make it true. The OR gate is an exclusive OR. Either one will make it true, but not both. An OR would have a 1 here, so that'd make it different. The NOR statement is both on or both off, but not an individual one. So actually an XOR is an opposite of an XNOR. And thank you for watching this tutorial with me, and hope you found it enjoyable. All the logic is built off of these simple basic instructions, which can be done on the face of the controller and can be a lot of fun to play around with, and we will try more statements in the future. Hope to see you at the next tutorial. Thanks.